Hi everyone. So let's start now. In this lecture, we will study three levels of schema in DBMS. So your DBMS software, I told you, yes or no? DBMS software, that is a software provided by many different companies, Oracle, IBM. Okay, so many companies they provide DBMS software. That DBMS software, okay, basically that provides three levels of schema. Okay, and why it provides three levels of schema? That also we will study. So basically, we will study three levels of schema. Your DBMS software will provide three levels of schema. Why it provides three levels of schema? That we will see. Okay, and what are these three levels of schema? That we will see. And then we will see data independence, this concept we will see. And then we will do some practice questions on the normalization. Okay, and relational algebra we will start tomorrow. Okay, in the next class we will start relational algebra. Basically today we will finish the normalization. Okay, completely. Not a single topic, not a small topic, okay, will be remaining. Okay, so today normalization will be completed. Normalization also the relational model. Okay, so these two topics, relational model and normalization, these two topics will be completed today. Yes, okay, Mavit, everything will be completed today. Okay, so today we will complete the complete normalization. Okay, every small, if there is a very small topic, that also we will complete. Okay, so today normalization we will complete, and then in the next class we will start relational algebra. So once this normalization is over, today normalization will be over. After that you can solve the go classes DBMS test 1. Okay, DBMS test number 1 on the normalization. That test you can solve. Okay, now let's see this. So let's start now. And tomorrow we will start the relational algebra. So next chapter, what is the next chapter? The next chapter is three levels of schema and data independence. Okay, this is our next chapter. What is three levels of schema? Why we want three levels of schema? Why DBMS provides three levels of schema? And this data independence. So these two concepts we need to see. Okay, so let's first see the first topic that we will see, that is three levels of schema. Like what are these three levels of schema? Okay, what are these three levels? So these three levels we will study, and then we will see why we want these three levels of schema. Okay, so basically this is a feature, these three levels of schema. This is provided by whom? This is provided by the DBMS. Okay, the database software, right? Yes or no? So the DBMS, like you have the database, here your database is there, this is your database, and there is a DBMS software, and there is a DBMS software. So that DBMS software that will provide you these three levels of schema. Okay, DBMS software. So these are provided by the DBMS software. These are provided by the DBMS software, these three levels of schema. Okay, and why DBMS software provides these three levels of schema? That is interesting. That is the important point. Okay, now let's start. So in a database, this is my first question. Tell me, in a database, should whole database, all the data, should it be visible to all the type of users? All the data, should it be visible to all the type of users? The answer is very simple. The answer is very obvious. The answer is no. Okay, for example, in a school database, if you have a school database, the children, the students, should they see the salary of the faculty? Okay, no, right? Yes or no? So in a school database, the students, they should not see the I can say information of another student, or I can say the students should not see the information about the faculty, or I can say the salary of faculty. Okay, so these things students should not see, and similarly faculty should not see the phone number of the student. Correct? Yes or no? Okay, nowadays privacy is everything, so you can notice that the faculty should not see, or I can say no student should see the phone number of another student. Correct? Is this clear to everyone? So basically different type of users, they have different type of access. For example, in a YouTube, okay, like sometimes you have this, on a Telegram also you have this, different type of users, they have different type of access, right? For example, if you have a Telegram group, if you have a, or WhatsApp group, okay, if you have a Telegram group or WhatsApp group, then in this group what we can do, different type of users, they can have different type of okay, there is a owner. Owner has access to everything. Owner has access to everything. Then you can, what this owner can do, this owner can create admins. Yes or no? And different admins can have different type of access. Different admins, they can have different type of access. Yes or no? So he can create moderators. He can create moderators. So different type of moderators. So I can say something like this. Is this clear to everyone? So different type of users, they have different type of access. Correct. Okay. Yes. In the bank database, one user should not see the, I can say, the account number or the account details of another user. Okay. So basically, what we want to protect. We want to protect. Say that we want to provide different views to different users. So different users, they must have different views. Is this clear? Okay, anyway, in detail we will see this. Okay, there is much more than this. What I told you, that is for security purpose, right? Okay, so far what we have seen, so far the explanation that I told you, that is for security purpose. But there is there is something else also. Okay, if user wants some specific data, if user wants some specific data, then you can provide that also. Okay, so basically that we will discuss. But is this clear to everyone? So this we will discuss what this like I can say, what users can see, what users can see, that we will discuss. But anyway, is this clear to everyone? That okay, so the whole database, or I can say the all the data, it should not be visible to all the type of users. So different type of users must have different views. Yes or no? I can say that. Okay, I can say different type of users, different type of users, okay, they must have different views of the database. They must have, they must have different views of the database, different views of data, or I can say database, or database. So they must have different views of the data, or I can say different views of database. Okay, let's move on now. uh Now let's see, consider this university database. This is a university database. This is the table for student. This is student table. This is faculty table, courses table, room table, enroll table, okay, teacher table, and so on. Okay, so this is your university table. Now tell me about this question. This is my second question. Tell me about the answer for this question. Select correct option. Okay, select the correct option. So what will be the correct option? What does the previous table data tells you? This previous data, what it tells you? Like basically, I can say, consider the university database. What this is telling you? What this is telling you? Is it telling you how the data is stored? Is it telling you on the hard disk how the data is stored? Is it telling you? Is it telling you on the hard disk how the data is stored? No. Okay. It is not telling you on the hard disk, on the hard drive, how the data is stored. It is not telling you in which order the records are stored. Yes or no? In every table there are records. In every table there are tuples. Okay. In every table there are tuples. But how those tuples are stored? Which data structure is used? Okay. Is it sorted? Is it unsorted? Okay. Basically, which data structure we are using? So basically, how the records, how the rows, how the tuples are stored on the hard drive, that is not told. Okay, we don't know that. We don't know how the data is stored. But what this tells you? This tells you what data is stored. It tells you what data is stored. Yes or no? Basically, this database, this university database, it will tell you everything about the data in this database. Yes or no? This university database, this database, it will tell you what data we are storing. This university, what data it is collecting, what data is it is storing. Okay, so the whole, I can say, what data we are storing, that is told. How data is stored, that is not told. And how users will see the data, that is also not told. So I can say, if you look at this, tell me what we call it. We call it schema. Yes or no? We call it concept. This is called conceptual schema. This is called conceptual schema. Okay, because conceptual schema, the conceptual schema, that will tell you what data we are storing. Okay, let's move on now. So this is the idea. Anyway, so let's move on. Now let's see this three levels of schema. So what happens? Let me tell you. Very simple thing. This is the final conclusion. You know that your database is stored where? Tell me. Where do you store the database? Where you will store the database? Some hard drive. Okay, because database is huge. Okay, maybe 1000 gigabytes, 1000 GB. Okay, 100 GB, maybe 1 TB, 2 TB, maybe 10 TB. Okay, 1000 TB. So I can say that database is stored. Database is used. So this is your database. This is your database. Okay, and this is your hard drive, or maybe something. Maybe basically this is the storage device. Okay, so here your database is there. Then you have DBMS. Then you have DBMS. This DBMS is an interface. Correct. Yes or no? This DBMS, it will provide you the interface. This DBMS, it will provide you the interface. So this is your DBMS. This is your DBMS software. Okay, so it will provide you the interface between user and database. This is your database, and here you have user, here you have some user. Okay, here okay, here you can have some user. So basically this data, this will provide you interface between database and users. Now this DBMS will provide you three levels of schema. Basically how the data is stored. Yes or no? How the data is stored. So basically the data DBMS, it will provide you, okay, how the data is stored. That is stored by physical schema. How the data is stored, how the data is stored, which data structure you are using. Okay, is the data stored in a sorted manner, unsorted manner? Okay, basically which indexes you are using. So how the data is stored, and all the details about the storage details, all the storage details, those are told by physical schema. Those are told by physical schema. So this physical schema, it will take care. This physical schema, it will tell you about the storage details, how the data is stored. Is this clear to everyone? How are we storing the data? Actually on the hard disk, how the data will be stored, that will be told by physical schema. So this physical schema will tell you how the data is stored. Okay. Next, after that, you can notice this conceptual schema. This tells you what data we have in the database. This conceptual schema, this tells you what data we have in the database. What data we have in the database. Okay, conceptual schema or logical schema. Another name is logical schema. Can you notice? So far in this, so far we have seen this. So far in our DBMS subject, so far we have seen this conceptual schema. So far we are dealing with the conceptual schema. Most of the time we study conceptual schema. So you can notice what is conceptual schema. It will tell you what data we have in the database. In this database, actually what data we have in this database. So it will tell you what data we have. It will tell you how data is stored on the hard drive. On this hard drive, how the data will be stored. And the final point, you can notice different users must see different data. Yes or no? Different users must see different data. External schema 1, different users, external schema 2, external schema 3. Okay, different users, they must see different data. This user can see this data, this user can see this data, this user can see this data. Is this clear to everyone? The three levels of schema. Okay, is this understood? The DBMS is providing you the DBMS software. It is providing you three levels of schema. Okay, and why? What is the reason? Can anyone give me very obvious reason? Very obvious reason to have this. Okay, just tell me very obvious reason to have this. Very obvious reason to have this. Okay, to give. Okay, yes, data. I can say privacy, security. Okay, basically data security, data authorization. Okay, data authorization, I can say security. So basically very obvious reason. So DBMS will provide you three levels of schema, and these are the three levels of schema. This is your DBMS software. It will provide you three levels of the schema. You can notice physical schema. It will tell you how data is stored. Okay, so this tells you how data is stored, how the data is actually stored. How the data is actually stored on the hard drive. Okay, how the data is actually stored. Okay, so how are we storing the data? Okay, how is stored. And what this conceptual schema tells you, this is also called logical schema. But what this tells you, what data we have in the database. What data in the database? In the database, what data we have? In the database, what data we have? Okay, and this tells you, this external schema, this tells you basically how are we using the data. How are we using the data? Yes or no? How are we using the data? This data, how are we using? Or I can say basically different access to the users. Okay, I can say this tells you use of data. This tells you use of data. How are we using the data? And we are giving different data to different users. Okay, is this clear to everyone? Okay, so different views of the data. Different users must have different views of the data. Okay, very simple. So this is your three levels of architecture. This is your three levels of DBMS architecture. Is this clear? Three levels of schema. Now, so you can very simply see that database is divided into schema and data. Every database. So the database you can divide into what is schema and what is data. What schema tells you, tell me? What schema tells you? Schema tells you the type of data. Okay, what type of data we have, and the data tells you what actual data we have. Yes or no? So this schema is basically, it will tell you what type of data we have, and this data, it will tell you what data we have. Okay, so that is the reason I told you that this is called instance. This is called instance. Okay, anyway, so finally what we have, the three levels of abstraction. Okay, the three levels of, I can say, schema. So we basically, the DBMS software, the DBMS, it will provide you three levels of schema, or I can say three levels of abstraction it will provide you. One is conceptual, physical, and external. Okay, very simple. You can notice that this is, here your data is stored, database, here your database is stored. Okay, and you can notice like this, different users can have different views of the database. Okay, different users, they have different views of the database. So this user has different view, this user has different view, this user has different view. Okay, and this will tell you what everything you have on the database, every data that you have on the database. So this will tell you what data we have, and this will tell you how the data is stored. Okay, so very simple. You can notice external schema, it will tell you use of the data. Conceptual schema, it will tell you meaning of the data, or I can say what data we have. And internal, this, remember, this physical schema, it is also called internal schema. This physical schema, we also call it internal schema. So these two are same. So remember, this internal schema, this internal schema, this is also called physical schema. This is also called physical schema. And this conceptual schema, this is also called logical schema. This is also called logical schema. Okay, so now so you can notice, very simple, internal schema or physical schema, it will tell you how the data is stored. Okay, let's move on now. So let's see one by one. Okay, three levels of schema, let's see one by one. The first is conceptual schema, or you can say logical schema. For example, this is your logical schema, yes or no? This is your conceptual schema. So the conceptual schema will tell you what data we are storing in the database. Okay, so conceptual schema, what is going to tell you? This conceptual schema or logical schema, what it will tell you? It will tell you what data we are storing. Okay, what data is stored in database. Okay, what data is stored, what data we are storing in the database. Okay, or I can say basically what tables are there. Okay, what relations are there, what tables we have, what relations, what tables we have. Okay, we have, okay, what tables or what relations are stored in database. So it tells you everything about what is stored on the database. It will tell you everything about what is stored on the database. Okay, is this clear to everyone? So for example, here it will tell you everything about what is stored on the database. Now very important thing I want to tell you, that for example, if you have a table, let's assume you have a, in the conceptual schema, let's assume this is your conceptual schema. Okay, in the conceptual schema, let's assume in the conceptual schema, I give you a relation. Okay, I give you some relation. I give you, let's assume I give you this relation student. Okay, where you have student ID and student name. Okay, I give you this schema. Now you can notice that in the conceptual schema I am giving you. Okay, in the conceptually I am telling you that okay, this data we are storing. Okay, so in the conceptual schema, whatever I tell you, is that stored on the database? In the conceptual schema, whatever I tell you, in the conceptual schema, whatever I tell you, whatever tables I tell you, whatever I can say, whatever data I tell you, or I can say whatever relations I tell you, are they stored physically? Are they stored physically? Yes, they are stored, right? Yes or no? I told you conceptual schema means what data we are storing, what data we are storing on the database, what data we are storing. Okay, so physically it is, remember, it is stored physically. Remember, it is stored physically. Is this clear to everyone? It is stored physically, or I can say, it is stored on hard drive. It is stored in a hard drive, in disk. Okay, so this will be stored. But the point, very simple point, you can notice. But so, for example, it will not tell you how the data is stored. For example, if I say 10 and their name is, okay, let's assume the 11, the name is B, and let's assume 9, Okay, the name is C, or maybe the name is A. So now you can very simple see that. Tell me, on the conceptual schema, from the conceptual schema point of view, from the conceptual schema point of view, from the conceptual schema point of view, can you say what is the first record? From the conceptual schema point of view, can you say what is the first record? What is the first record? Can you tell me what is the first record? There is no first record. There is no first record. Yes or no? This is a set. This is a set. So from conceptual point of view, from conceptual schema point of view, this is a set. This is a set. Okay. So there is no first tuple. I can say there is no first tuple. There is no first row. There is no second row. There is no third row. Yes or no? There is no second row. There is no third row. Is this clear to everyone? Okay. From the conceptual schema point of view, we don't care about the order of, okay, because this is a set. So there is no first row, there is no second row. These things are not there. Okay, these things are not there. Very simple. Now, but tell me. Okay, but when you actually store this data, so from the conceptual schema point of view, I can say every relation is a set. I can say every relation is a set. Agree? Every relation is a set from conceptual schema point of view. But tell me, okay, so this conceptual schema, it will not tell you it will not tell you the order. Okay, but basically we know that, okay, these three tuples we have, we know that there are these three tuples, but how they are stored? So from physical schema point of view, okay, tell me, physically when you store them, then there will be some order. Agree or not? Physically when you store them, there will definitely be some order. Okay, so physically when you store them, then there will definitely be some order. Maybe you are storing in the sorted order, maybe you are storing in the unsorted order. So maybe physically you are storing in the sorted order. Okay, so this in the sorted order, maybe you are storing. So maybe you are storing like this, okay, 10A, okay, something like this. Yes or no? Maybe physically you are, okay, physically schema point of view. Okay, so maybe you are, okay, sorted order. Is this clear? Is this clear? Sorted order, or maybe unsorted, or maybe unsorted order, or maybe unsorted order, or maybe unsorted order. So everything is fine. Okay, from physical schema point of view. So physically how the data is stored. So is this understood? Is this clear to everyone? Conceptual schema versus physical schema. So conceptual schema will tell you what data we are storing. It will not tell you how the data is stored. Physically, which data structure we are using. Yes or no? Some data structure also we are using, correct or not? Definitely some data structure also we need to use. If you are storing the data, okay, in the, okay, finally when you store the data, then some data structure you must use. Which data structure you are using, it will not be told by conceptual schema. This conceptual schema will not tell you which are the data structure we are using. For example, B tree, B plus tree. Okay, which data structure we are using, that is not told by this conceptual schema. So conceptual schema will tell you what data we have. It will not tell you how the data is stored. It will not tell you what data structure we are using. It will not tell you what are the indexes. All these things will not be told. Okay, is this clear? Arnab is saying in the conceptual schema we are storing instances. No, conceptual schema is basically telling you what data types you are storing. Arnab, think logically. All these concepts, think logically. Conceptual schema will tell you what data you are storing. And this will keep changing. It is not a fixed thing. It is not a fixed thing. It will keep changing. This I have taken just for example. Just to explain this example I have taken. Just to explain this example I have taken. This is your conceptual schema. Remember. Is this clear? This is your conceptual schema. The data will keep changing. The data will keep changing, but this is your conceptual schema. The conceptual schema is telling you what data we are storing in the database. In the database, what data we are storing. Okay, and basically what type of data we are storing, or I can say, if you want, I can say what type of data we are storing, or I can say what type of data we are storing. Is this clear? The actual data, it will keep changing. It will actually keep changing. Okay, so is this clear? Now let's move on. So the conceptual schema or logical schema, it will describe the data that is stored. Okay, what data is stored on the in the database, that is told by conceptual schema. Okay, is this clear? So like for what relations we are storing, I can say all the relations that are stored on the database. Okay, so all these things. Now let's move on. Now one important thing I want to tell you here. So for this conceptual schema, that it will not tell you. Okay, can you notice? See this, see this statement. This is important. So this will not tell you what, this conceptual schema, it will not tell you what, the conceptual schema, it will not tell you the data representation, how the data is represented. Okay, how the physically it is organized. Okay, so how it will be accessed. So basically these things, how it will be accessed. Okay, how so these things are not told by the conceptual schema. So for example, very simple. And one more thing, that tell me one thing. Most of the time, whenever you have a database, let's assume there is a database, let's assume this is your database. Okay, and let's assume this is your DBMS software. This is your DBMS software. Okay, now let's assume you are the application programmer. Let's assume you are the application programmer. Okay, for some specific application, you want to write some program. Okay, you are the application programmer. Depending on the requirement, we write the programs, correct or not? Yes or no? Depending on the requirement, it's not like you have fixed set of program. Okay, depending on the requirement, we keep writing different programs. So let's assume you are the application programmer. You will write some program. For example, your company will tell you that we want this type of data. Okay, your company will tell you we want this type of data, or we want to store this type of data, we want this data in this format. Okay, something like this. Okay, so now in this situation, what you will do, you will write the program, you will write an application program. But tell me, most of the time this application program, okay, this application programmer, or I can say most of the time when you write application program, okay, that I can say that you write on which schema. Okay, tell me, most of the time the application program that you will write, that application, most of the application programs, they basically they deal with what? Okay, you write them on which schema? You write them on conceptual schema, yes or no? You will write them on the conceptual schema. So most of the time, most of the application programs, you will write on the conceptual schema. What data we are storing? Okay, yes or no? So most of the time, there are of course you can also write some application programs which will deal with the physical storage. You can also write, but most of the time, most of the application programs, they deal with the conceptual schema. Okay, basically this application programmer, most of the time he only cares about what data is stored on the database. Okay, how are you storing, he does not care most of the time. So this is what I'm saying, most of the time I can say this is your application program. Let's assume this is your application program. Now most of the time it is written, it will deal with, I can say, conceptual schema. Okay, most of, I can say, most of application programs, so let's call it AP. Okay, most of the application programs, they deal with what? They deal with, or I can say they are written on conceptual schema. They deal with conceptual schema, or I can say are written based on conceptual schema, are written based on conceptual schema. Okay, most of the time actually data retrieval is the main important part. Okay, most of the time in any company, for example Amazon, tell me what is the most important I can say feature of the Amazon. Like what is the most important from the Amazon point of view, from the company point of view, what is most important? The most important is that when the user will search the data, it should immediately get the data. Yes or no? Search is very important. Yes or no? If you notice all the big companies, the Google is such a big company, but actually what Google is doing? Google is only giving you the data. So the most important part is basically the database, the data retrieval. Most important part, that is data retrieval. Can you retrieve the data? Can you retrieve the data? So that is the reason I am saying that the data retrieval, when you are retrieving the data, then tell me, then most, okay, you will basically care only about the conceptual schema, what data is stored, correct or not? What data is stored? So Google will give you this data, or Google will give you this data. Okay, So basically, that is the reason I can say most of the application programs, they basically they are written based on the conceptual schema. What data is stored, or I can say most of the application programs, they basically they are written on the retrieval of the data. We want to retrieve the data. Most of the application programs, they want to retrieve the data. Some data they want to retrieve. Some data they want to retrieve. Is this clear? So they are written based on conceptual schema. Now, one more thing. One more thing. Now, very simple thing I want to ask you. This we will study in the SQL, but let's assume now you have the schema. Okay, let's assume you have some schema you have. So let's assume you have conceptual schema. So this conceptual schema, it will tell you this conceptual schema. It will tell you what data we are storing. For example, let's assume you have conceptual schema student. Okay, student, and in this student table, let's assume you have a student ID, you have a student name. So these things you have. Okay, and now let's assume you write a retrieval query. You write a SQL query. Okay, SQL query to retrieve data. To retrieve data. You want to retrieve data. Okay, so whenever we want to retrieve data, then our query should be based on what? Whenever we want to retrieve the data, our query should be based on conceptual schema. So now you will write some query. Maybe some query you will write. Okay, you will write, for example, select those SIDs. Give me those SIDs. Give me those SIDs. Okay, where give me those students. Give me those students. Okay, select those students where name is I can say where name is John. Is this clear? So something like this. Okay, so is this clear now? So we are basically we are writing the SQL query. Okay, we are writing the SQL query, and we are saying that select those students. Give me those SIDs where the student is, where the name is John. Now tell me, when you are writing this, at the time, do you care how the data is actually stored? Do you care how this data was actually stored physically? How the data was stored? When you write this query, do you care how the data was actually stored? We don't care. Okay, basically we only care, give me SID whose name is John. You give me this. One more thing. When you are writing this query at that time, this query, does it tell you? Because I can say, okay, let's call it application program. Let's call it application program. Okay, let's call it application program. This is a simple query. Okay, and let's call it a simple application program. So this is your application program. Now tell me, this application program, does it care about the physical? No, it does not care. Also one more thing, that when you are writing this program, are you telling the database, are you telling the DBMS in which order you want the data? Are you telling the database in which order you want the data? No. Yes or no? We don't know. We are not telling anything about in which order we will get the data. We don't know in which order we will get. Okay, I don't know. For example, maybe I will get in this order. Maybe I will get in this order, unsorted order. Yes or no? Maybe I will get in unsorted order, or maybe I will get in sorted order, or maybe I will get in sorted order. I don't know. Okay, I don't know in which order I will get the data. So I'm not telling in which order you give me the data. Okay, I'm not telling, I'm not concerning about the physical storage details. So this is the simple idea, that this application program, it only cares about what data you want, and it only cares about the conceptual schema. Is this clear to everyone? So this application program, this only cares about the conceptual schema. This application program, so this only cares about the conceptual schema. So finally, I can say that this, when you write this, then okay, these things are irrelevant. Okay, the order of retrieval. Okay, retrieved tuples. I can say order of retrieved tuples. Okay, is irrelevant. Okay, or I can say doesn't matter. In which order you are, okay, doesn't matter. Also, one thing I can say, that also doesn't care about how the data is stored. Doesn't care about how the data is stored. Okay. Anyway, so this is the point. So this is your conceptual schema. Did you understand conceptual schema? Tell me. So remember, if you write application program based on conceptual schema, then it will not care about the physical details. It does not care about the physical details. So when you write application program based on conceptual schema, then it will not care about the physical details. Okay, so very simple. Also, it will not care about the access details, like in which order you are getting the records. Okay, in which order you are getting the records. So that also is no, that also does not matter for this application. So this is the final point. Okay, now let's move on. Now let's see the physical schema. What is physical schema? Let's see the physical schema. The physical schema is basically telling you, or I can say internal schema. So what this physical schema? This is telling you how the data is stored. How are we storing the data? Okay, are we storing the data in sorted order, or are we storing the data in unsorted order? Sorted, unsorted, or also which indexes we are creating on the database? Okay, which indexes we are creating, which data structure we are using. So basically all these things. Okay, so the physical schema will tell you, like all the data structures that we are using. Okay, how we are storing the data. Are we storing the data in sorted order, unsorted order? Which indexes we are creating? Okay, so all these things. How are we storing the data? So very simple point. Is this clear to everyone? This is your physical schema. So physical schema will tell you about the storage details. Okay, so for example, this is your conceptual schema. Now this is your conceptual schema. So this is your conceptual schema, but physically it will be stored. Agree? This is your conceptual schema, and physically it will be stored. So when you store it physically, this is logical. Okay, that this is the data. So this is your conceptual schema. But when you actually store this, when you actually store this, when you actually store this, this is your physical. When you actually store this, then what will happen? Then basically you will find, okay, like is this sorted order? If this is in the sorted order, then which based on which field? Yes or no? You can do sorting based on birthday date. You can do sorting based on salary. You can do sorting based on last name. So basically how the data is stored. So this is the conceptual schema, but physically when you store this data, then how are you storing the data? Okay, how are you storing the data? Next, what indexes you are creating? What indexes we are creating? For example, in your notebook, in any book, whenever you study a book, then there is an index, right? Yes or no? In every in the beginning of every book there is an index. If there is no index, let's assume, okay, there is a, let's assume you are studying the, you are learning the DBMS book, and there is no index, then it will become very complicated. Yes or no? You will never read that book, because it will become very complicated to search the information, to get the information. Okay, that will become very complicated. Okay, so that is the reason in the database. Okay, so physically what we do, we create indexes. Now on based on what? Tell me very simple thing. Based on which field you will create the index? Based on which field you will create the index? Based on which field? Yes, primary key, that will automatically happen. Okay, based on primary key, the DBMS will automatically create the index. Okay, so this primary key, based on primary key, automatically DBMS will create the index. The DBMS software, it will automatically create the index. But tell me what you want. Okay, tell me, in a school, let's assume there is a school. In this school, in this school, okay, in this school, if you are searching for some detail, if you are searching for some detail, uh, will you search based on student? Like for example, most of the time, if you are searching the detail, are you searching in a very, I can say, in a very, what I can say, sophisticated manner? When you search a detail, then do you search in a very sophisticated manner? No. What you will search? Okay, in this school database, if you want to search for your students, for your friends data, okay, then you will just search the name. You will just search the name. Yes or no? Based on name, you will search based on name. So what? Okay, now this school owner, this school owner, or I can say database designer. Okay, this database designer, what he knows, what he knows, he knows, he knows that, he knows that. Okay, people are searching based on name. He knows that people are searching. People will search based on name. Correct? Yes or no? People will search based on name. He knows this. People will search based on name. Most of the queries will come based on name, based on student name. So what he will do in this situation, what he will do? Or remember, there is a already there is a on the based on the id, based on the student id, there is already a based on the primary key, already there is an index. Based on the primary key, already there is an index. But this database designer, he knows that people will search based on name. So what he will do? He will create a, okay, so he will create a index. So he creates an index based on name. He creates an index based on name, based on name, something like this. So these things, all these things, they are basically, okay, these, they come under the internal schema or physical schema. So this is your conceptual schema, what data you have, but how the data will be stored, how the data will be, I can say, what in which order you will store the data, which indexes you will have on the data, how many indexes will be there. You can have multiple indexes, okay, 2 indexes, 3 indexes, you can have multiple indexes. Which data structure to use, okay, will you use b plus tree, will you use b tree, okay, so in which, basically all these things, all the storage related things, those will be told by physical schema, or I can say internal schema. Okay, is this clear now? So let's move on now. So this is your physical schema. Now let's see the next. The next is external schema. What is this external schema? Or I can say this is basically the schema that is viewed by users, what users are going to see. So here two things will come. Okay, for example, the first thing is in this external schema, basically this external schema basically means how the users are going to see the data. Okay, this external schema, in this external schema, how the users are going to see the data, and different type of users, they should see the different type of data. So for example, I can say that this student, he should not see the salary of faculty. The student should not see the salary of the faculty. So I can say that different users, different type of users, there can be different type of users. What are the different type of users? For example, admin, super admin, okay, moderator, okay, employees, students, okay, something like this. So these are the different type of users, correct? Now different type of users, they can view different type of data. Okay, so this is a very simple point. But there is one more thing, there is one more thing. So this student should not see the salary. So this comes under what? I can say this comes under data privacy. Can I say? Can I say this comes under data privacy? So I can say that data privacy. Okay, so I can say external schema. So it will take up it this external schema. So I can say different basically views users, what users can see. Okay, this external schema, it tells you what users can see. Okay, what users see, what users see. So this is the idea, how the data will be used, basically how the data is used. Okay, I will explain this, how the data is used. Okay, this is important, how the data is used, how the data is used. So let me give you the first example. The first example is very simple, that okay, I can say data privacy. Okay, I can say data privacy. So the first example is very simple, the data privacy. Or I can say that students should not see salary of faculty. A student should not see salary of faculty. Salary of faculty. Okay, so something like this. Now the second thing, but how the data is used, that will come under what? How the data is used, that will come under what? Now very simple thing, let's see. Let's assume you are storing the date of birth. In the database, you will store what? You will store the database. Will you store age? Will you store age in the database? Will you store age in the database? Will you store? Why no? What is the reason no? Will you store age in the database? Why are you not storing the age in the database? What is the major thing? It will keep changing. Every second it is changing. Every day it is changing. Yes or no? Every day, every second, every month, every year it is changing. Okay, it is very dynamic. Every minute, every second it is changing. The age is changing. Yes or no? So this is what I'm saying, that so very simple thing, that in the database you will not store, or I can say in the conceptual schema we don't have age. Agree? In the conceptual schema, in the conceptual schema you don't have age. In the conceptual schema, let's assume you have date of birth, you have date of birth, but you don't have age, but you don't have age. Okay, in the conceptual schema You have date of birth. Date of birth is there, but this we will not store. Very simple. You know how? Okay, you know why? Because it will keep changing. So that is the reason in the conceptual schema you have date of birth, but you will not store the age. But what user wants? But what user will want? User wants date of birth or age. Most of the time we are concerned about age. Immediately we want age. Yes or no? Immediately. Let's assume Sadi.com. Let's assume we are creating the website for Sadi.com. Then what we want? We immediately want the age. Just give me the age. Okay, we will just okay. So basically, what users want? Tell me how this data will be used. How this data will be used? Okay, what users want? Tell me what users want. Or I can say, how this data will be used. Okay, how this data will be used. How this data will be used. This data, how this data will be used. Tell me. So this data will be used, okay, for I can say age purpose. So what users want, okay, and how the data will be used, that will be used for age purpose. They want age. So what we can do in this situation, what we can do, but we don't have age. On the conceptual schema, we don't have age. Agree? So on the conceptual schema, we don't have age. There is no field for age on the conceptual schema. In the conceptual schema, you have a student. Okay, there is a student table. Let's assume this is the student table. In this student table, you have a student ID, student name, and there is date of birth. But there is no field for age. But what? Okay, but what is the external schema? What is the external schema? What? Okay, what is one possible external schema? External schema one. What is one possible external schema? That is basically this. Okay, I don't want to give the exact date of birth. Let's assume for privacy again for privacy. Let's assume I don't want to give date of birth, but I want to give as name and let's assume age. These two things I want to give. Is this clear to everyone? Okay, I will give the age in the years. I will give the age in the years. Okay, like in the years I will give the age, but I will not give the date of birth exact. Okay. Very simple. So is this clear to everyone? So this is your external schema one. How this data will be used? How this data will be used? So is this line understood? This external schema, is this line clear to everyone? How this data will be used? How this data will be used? Or I can say what users see, or I can say what will be the user see. Okay, very simple. Now one more thing. Tell me, this is we are storing. Can you notice this is stored? Can you notice this is stored? Can you notice this is stored? This is physically stored. Okay, this is actually stored. Is this stored? Tell me, are we okay? Is this stored on the database? Is this stored on the database? Remember, external schema is not stored. This is very important point. It is not stored. This external schema, it is not stored on database. It is not stored on database. It is derived. It is derived based on user requirement. From what? It is derived based on user requirement from conceptual schema. So it is derived based on user requirement, from conceptual schema, Clear? Okay. Now Mavit is asking who will derive it. So tell me who will derive it. Application programs will derive it. You will write the application programs depending on the user requirement. Okay, Mavit, is this clear? Depending on the user requirement, you will write the application programs. Okay, so the application programs, they will derive it. So you can notice who derives it. Who derives this external schema from conceptual schema? Okay, so very simple, that the application programmers. So application programs, we will write the application programs. Okay, and remember, these things will keep changing. Like application programs, they will keep changing. For example, today you have some application program, and tomorrow your boss will tell you, give me one more application program. Yes or no? For example, let's assume that on the Sadi.com, on this website, let's assume people are searching by age. Let's assume on the Shaadi.com, people are searching by age. Then what the boss will tell you? What the boss will tell you? The boss will tell you that, okay, give me write one program. Okay, quickly write one program so that people can quickly search based on age. Okay, is this clear? Write one program, okay, which will give the users can see the age. Write one program so that users can see the age. But okay, very simple point. See, the users are searching based on age. User want age, but what you have date of birth. So what you will do? You have date of birth, user is wanting age. So what you will do? You will go to the application program, you will go to your employee and you will tell him, okay, write a program so that from the date of birth, the users can see the age. The user should not see the date of birth, user should see the age. Okay, so you will write a program. Then the next day, okay, after 1 month, what will happen? After 1 month, let's assume people are searching based on something else. People are searching based on maybe I can say yes, caste. Yes, okay, so people may be searching based on caste, or people may be searching based on something else, for example maybe occupation. Okay, so basically these things will keep changing, yes or no? So the external schema, it very much depends on what? This external schema, it very much depends on what? It very much depends on user requirement, yes or no? It depends on the user requirement. The user requirement keeps changing. Okay, what user is wanting, that will keep changing. So we will also keep writing the programs. That is the reason these companies are running. Just think about it. If you write all the programs one time, sometimes I also think like this. The Dream 11, for example, let's assume there is a app, Dream 11 or Zomato. Okay, but let's assume there is a app. Now sometimes you might be thinking, like, once everything is done, like what people are doing, okay, those employees, those programmers, what they are doing. So they keep doing something, they keep writing more programs. Okay, they keep upgrading the programs, new programs. Okay, so depending on the user requirements, so everything, so these things keep happening. So is this clear to everyone? So okay, remember this external schema. So this application programs, okay, they will derive the this external schema. And remember, this external schema, it basically, it depends on the user requirement. It depends on the user requirement. Okay, so it is basically, I can say, it is very much dependent on user requirement. What is the user's requirement? User requirement. Is this clear? It is dependent on user requirement. Okay, so this is the idea. So like this. Now, so this is your conceptual schema, and this is the external schema. So I hope this point is clear. So very simple. So what data we are seeing, data, the so like this, you can notice. So this is the point. If you have this table, then you can create a view like this. You can write the program. See, we don't care about the details of this program, but this is your application program. Some students are asking, for example, this is your conceptual schema. Okay, correct. This is your conceptual schema. So this is your conceptual schema. This is the actual data that is stored. This is the actually this data is stored in the database. In the database, this is the data that is actually stored. Now what will happen? Now this is the external schema. This is the external schema. This is your external schema, or I can say external schema 1, because there can be many different external schema. From this conceptual schema, how many external schema you can create? From this conceptual schema, how many external schema you can create? Many. Okay, you can create many. You can keep creating. Okay, so many external schema you can create. So you can notice this is one external schema. Okay, let's assume, for example, in this table, do we have current city? In this table, do we have current city? In this table, do we have current city? We don't have current city, but okay, but we can derive this current city. We can derive this current city. Okay, so something like that. Okay, maybe based on some information, maybe we can derive this current city. Okay, so here actually it is not here it is not clear how are we going to derive the current city, but maybe there is another table. Maybe there is another table. Based on two tables also you can derive. Remember this external schema, do we derive this from one table or another table? This external schema you can derive from many tables. In the conceptual schema, let's assume this is the conceptual schema. In this you have relation R1, in this you have relation R2, in this relation R3, in this relation R4. Now remember, in the external schema, you can derive from this, you can derive E1. From these two you can derive E2. Is this clear? From these two you can derive E2, and maybe from these three, and maybe from these three, from these or I can say from these three, maybe you can derive from these three, you can derive external schema 3. Is this point clear? Let me give you one example for this also. This is your external schema 1. This is your external schema 2. Let me give you one example here also. For example, see this. Okay, look at this. Let's assume that users are wanting this. Okay, what user wanting? The users are wanting for which course, which faculty is there. Correct or not? This is in a school. What you want to see in a school, in any school, you want to see which course is taught by which faculty. Like this course, which faculty he is teaching. This course is taught by which faculty, and how many students are there in this course. How many students are there? So these three things. What you want? You want, okay, this course is taught by which faculty, and how many students are there in this course. In this course, how many students are there? Okay, number of students. This is number of students, integer. So this is your number of students. Now tell me, do you have this stored on the conceptual schema? Is this stored? Do you store number of enrolled students? No. So how can you derive it? How can you derive it? You can see the enroll table and you can count. You can see the enroll table and you can count. Yes or no? From this enroll table you can count. You can count. Agree? Okay, from the enroll table, from this enroll table you can count. Also, what is the second point? You can notice this information is also not in a single table. If you notice this database, in this university database, this information is not there. In a single table, we don't have this information. This course is taught by which faculty? This information is not there. Yes or no? This course is taught by which faculty name? The faculty name. Can you notice here also faculty name is not there? Yes or no? Here also faculty name is not there with the course. Here also faculty name is not there with the course. So in single table, we don't have this data. In the single table, we don't have this data, but users will want this data. Most of the time in any university, in any college, most of the time user will want this data. This is the most important data from the user point of view. Yes or no? From the user point of view, this is the most important data from the user point of view. So what users want? So I can say what users want. So from the user point of view, this is the most important data. They want, okay, like they want what is the course ID, what is the faculty name, what is the faculty name, and number of enrolled students, and number of enrolled students in this course. Number of enrolled students in this course. So this is very important data from the user point of view. But this data we don't have in the database. Agree or not? We don't have this data in the database. This table is not in the database. Agree? This table is not on the database. So you can notice that this table, okay, so I can say this table is not stored on the database, is not in database, is not stored in the database. Or I can say, because this table is not in conceptual schema. Agree? This table is not in conceptual schema. So what we will do in this situation? In this situation, we will derive it. We will derive this, correct? So we will derive this from this table, and from this table. From these three tables, we will derive it. From these three tables, we will derive it. From course, enrolled, teacher. From these three tables, we will derive it. So I can say this will be derived. Okay, remember, this will be derived. This will be derived from these three tables, from three tables of conceptual schema. From three tables of conceptual schema, it will be derived. From three tables of conceptual schema. Clear? Tell me, is this clear to everyone? So this external schema concept, is this clear to everyone? This external schema concept, is it clear? So very simple, that you can derive it. So you can derive the external schema. So very simple, and like this you can derive. Like this you can derive. Okay, so this is your, I can say this is your application program. You can call it application program. This program will create this external schema. This external schema will be created by this program. So this program is going, this application program, okay, will create this external schema 1. Okay, is this clear? So like this. Okay, don't worry about the details. Okay, no one will ask you this. Okay, how? But what I'm saying, I am saying that this program. Okay, I am saying that this program will be, yes, views are temporary. When you say views are temporary, what it means? Nikhil, what it means? Views are temporary. Remember, view is basically a program. This is the program. If you don't want this program, you can delete this program. No, no, Nikhil, view, you are not understanding what is a view. You are not understanding what a view. View, view is basically this program. This program is the view. So when you access this program will give you, see, okay, when you access this program, when you access this program, then this program will create from this, the program will create this. So basically this is not stored. Okay, what you are saying, that is correct. This is not stored, but this is visible to the user. Okay, is this clear? This is not stored, this is visible to the user. So whenever the user will send some query, okay, this will happen when the user will send some query. Okay, let's assume when the user is sending some query. Now in this situation, what will happen? So let's assume when the user is sending some query, let's assume, okay, let's assume, let me remove it completely. Okay, so here what will happen when the user is sending some query? So this is some user. Okay, so when the user will send some query, okay, he wants something. Let's assume he wants this information. This information he wants. Okay, wants to know. Okay, so let's assume he wants to know uh, high pay females. High pay females. Again, this is a sadi.com website. Okay, so let's assume this user want to know high pay females. Definitely he is going to, I can say, he is not having a correct mindset, because okay, so he want to marry high pay females, let's assume. Okay, very simple. Okay, so let's assume this user want to marry high pay females, but this data is not stored in the database. Yes or no? This data is not stored on the database. Agree? Okay, please understand step by step. Please understand, this is very simple point. Okay, just understand this. Many students, many people, they don't understand this concept. Okay, they just know, okay, what is external schema, what is internal schema, but you should understand this. Okay, let's assume this user is wanting, this user wants to know high pay females. He want to marry. Okay, let's assume this user want to marry, and he want to marry a high paying female. Then what he will do? But this data is not stored on the conceptual schema. This data we don't have. This data we don't have on the table, on this table in the database. We don't have this. So what you will do? But you are very smart. You are the database designer, or I can say you are the application programmer. You are the application programmer. You already have a program for this. So when this user will want this data, then this user program will be called. This program will be called. Then okay, this program will be called. This program, what this program will do? This will, okay, this will take from this is stored in the database. So from this conceptual, I can say, from this stored data, this data is stored on the database. From this it will create the conceptual external schema, and then it will go to the user. Tell me, is this clear? Let me know. Okay, so very simple. So like this, you can create many external schema. External schema is basically is just an application program. You are writing a program, very simple. You are just writing a program, and like this, it will happen. Okay, tell me, is this clear? So what is external schema? That is basically parts of information, okay, that we want, that a user want to see. It is derived from conceptual schema. Remember, it is not stored. It is derived from the conceptual schema. It is not stored. So very simple point I'm saying. And tell me one more thing. It is derived from the conceptual schema. So if I change the conceptual schema, will I have to change this program? Will I have to change this program? Will I have to change this program if I change the conceptual schema? Yes, definitely. Agree or not? So very simple point. This is another important point. This is another important point. If I change the conceptual schema, okay, if we change conceptual schema, there is possibility. I am not saying that this is okay. Tell me, is it necessary? You have to change it. Is it necessary? You have to change it? No. So if we change the schema, there is a possibility to change. Okay, there is a possibility. a possibility to change. Okay, possible to change this. So if you change the scheme conceptual schema, then okay, then possibly have to change, then possibility have to okay, we have to change this application program also. Correct? This application program also we have to change. Okay, is this clear? So this is derived from the conceptual schema. So if you change the conceptual schema, then it is possible. It is possible to change this. It is possible to change this application program also. Okay. Now let's move on. So let's see this. Why we have these three levels of schema? All the three levels of schema. Why we have them? So before that, let me just give you some details, some important points. Okay, this is the conclusion of the important points. Now Arnab is asking one doubt. Let me answer that doubt. Arnab is asking at least 5 messages Arnab has sent. So okay, this data I took only for the, remember, this data I took only for the this instance I only took for the understanding purpose. Arnab, is this clear? This I took only for the understanding purpose. It is like this analogy. Okay, tell me. Remember, this is conceptual schema. Please understand, this is conceptual schema. Please understand, this is conceptual schema. So this conceptual schema has nothing to do with the instance. The instance will keep changing. The instance will keep changing. The conceptual schema has nothing to do with the I can say with the instance. So the conceptual schema is this. For example, a student table, okay, student ID, a student name, okay, and date of birth. Is this clear? This is conceptual schema. This is conceptual schema. Is this clear? The data will keep changing. The data will keep coming, keep going. Okay, the data, we don't care about the data. Conceptual schema is telling you what data we are storing, what data type we are storing, which type of data we are storing. So these three data we are storing. Conceptual schema is telling you that in the database, you will store this. You will store this information, you will store in the database. This information for any student. This conceptual schema is telling you that passport number you will not store, age you will not store. Is this clear? Number of students you will not store. So the conceptual schema is telling you age will not be stored, passport number will not be stored. Okay, number of students will not be stored. Is this clear? So the conceptual schema is telling you what information we are storing in the database. So this information we are storing in the database for every student. For every student, this information we will store in the database. And what this physical schema will tell you? What this physical schema will tell you? This will tell you how we will store this data. This data we will store. Okay, so this conceptual schema is telling to be stored. To be stored. To be stored. Okay, this physical schema will tell you how we are storing this. How is it stored? How is it actually stored? Which data structure you will use? How is it actually stored? Okay, and what this external schema is telling you? What this external schema? Give the information that user wants. Yes or no? Give the information that user wants. What user wants to retrieve. So this external schema, it will tell you, give user what he wants. Or I can say how user will retrieve the information. How user retrieves information. Okay, so for example, let's assume the user wants this. The user does not, okay, user does not want this table name also. So let's assume user wants the table name should be this. How old? The table name should be this. The user is saying the table name should be this. Okay, the user is saying the table name should be this, and just give me the S name and just give me the age. Okay, is this clear? So very simple. So this is okay. From this you will derive this. From this you will derive this. Correct? From this you will derive this. Who will derive? Tell me. Who will derive? The application program. The application program. And can you notice? Can you notice? In the application program, we don't have this instance. Arnav, is your doubt clear? Look at the instance. Look at the application program. Is there any instance? Is there any instance? Look at the application program. Is it dealing with schema or is it dealing with the instance? Tell me, is this application program dealing with the schema or is this dealing with the instance? This is dealing with the schema, conceptual schema. Is this clear? Anyone has any other doubt? Tell me, anyone has any other doubt? Is this clear? So remember, this is conceptual schema. What data we are storing to be stored? How are we storing? This is physical schema, and external schema means how are we going to use it? Okay, this three level of architecture, three level of DBMS architecture. Is this crystal clear? Three level of DBMS architecture. If anyone asks you, can you explain in any interview? If anyone asks you, what is external schema, what is conceptual schema, what is physical schema, can you clearly explain? Clearly, okay, very clearly, can you explain? Okay, so anyway, this is your external schema, all the concepts. Now remember the conclusion. Let me give you the conclusion. The conclusion, some important points. First of all, this external schema, this is derived from what? Remember, this is derived from conceptual schema. Okay, this external schema, this is derived from conceptual schema. The second point, this external schema is not stored. Okay, is not stored. It is derived. Okay, so this, can you notice this table? Look at this table. Look at this table. Can I say this is a I can say this table is not stored? Yes or no? Can you notice this table is not stored? But this table is, can I say, can I call it virtual table? Can I call it virtual table? So I can call it virtual table because it is not stored. It is just a virtual table. It is not actually stored. It is just a view into the database. It is just a view into the database. How the user will see the database. Okay, from the user's eyes, from the user's point of view, how he will see the database, how he will see the database. So basically, this is a virtual table. Okay, so I can say this I can say this external schema is a virtual, I can say it is a virtual table. It is a virtual table. What it means? It is a virtual table. What it means? It means not stored, not actually stored. It means it is not actually stored in database, but user can see this, but viewed by user. Okay, but viewed by user. Or I can say this is an illusion. Can I say this external schema? This is like a illusion. This is like a illusion. Okay, this is like a illusion. You are thinking that database is like this. You are thinking database is like this, but database is not like this. Yes or no? You are thinking this information is stored. You are thinking this information is stored, but this is not stored. Correct? So very simple. So it is like a illusion, or I can say, okay, anyway. So I hope you got it. So anyway. So like this. So this is some conclusion, and okay. And from conceptual schema, yes, the third point, the fourth point, from conceptual schema, you will go to the physical schema. Agree or not? From the, okay, based on that, based on conceptual schema, you will create the physical schema. Based on conceptual schema, you will create the physical schema. Okay. Conceptual schema is more or less fixed. Okay, conceptual schema, that is more or less fixed. This conceptual schema, it is time invariant. It is time invariant. Of course, you can change it. Of course, for example, next year, if you want to change some, if you want to, it will rarely change. Or I can say the conceptual schema, it will rarely change. It will rarely change. Of course, it can change. Of course, you can change it. Okay, but it will rarely change. So you can call it time invariant. Is this clear? The conceptual schema, it rarely changes. But the external schema, it will change frequently. Yes or no? This external schema, it will change frequently based on the user requirement. Agree or not? This external schema, okay, are this external schema are created, okay, different. This external schemas, These external schemas are created. I can say these external schemas are created based on user requirement, based on user requirement, based on user requirement. And this is based on our requirement. And this is based on our requirement. Yes or no? And this is based on our requirement. And this is based on user requirement. And they are created. Okay, anyway. So let's see why we want these three levels of abstraction. What is the reason? What is the reason we want three levels of abstraction? Why? Like why we want these three levels of abstraction, three levels of schema, or I can say three levels of abstraction. You can call it three levels of schema, or you can call it three levels of abstraction. So I can say that the very simple point is that, okay, of course, different users should have different. This is the very simple, that access control. Okay, the one application is access control. Different users should get different visibility. This is the very simple. Okay, and what is the second point? Okay, what is the second point? The second point is data independence. This is very important. This is very important. Okay, can you notice? Can you notice when you change the conceptual schema and the external schema is derived, the external schema is not stored, that is derived. Yes or no? So if you change, tell me, if you change one level, if you change the conceptual schema, there is a possibility you may have to change the external schema. Basically, there is a possibility you have to change the application programs. Yes or no? So now let's see the concept of data independence. Okay, there are two type of data independence. One is physical data independence, and another is logical data independence. One is physical, another is logical data independence. Now let me tell you very quickly what is physical data independence. What is physical data independence? This PDI. Okay, physical data independence. What this means? This simply means that independence due to physical changes. Okay, independence independence of conceptual schema. Okay, of conceptual schema from from physical changes, from physical changes, from physical changes, from physical changes. Okay, this is this clear? Like if you change the, for example, let's assume you are using B tree. Okay, one day you are using the B tree and next year you use the B plus tree. Okay, tell me, does the conceptual schema care about it? Will you change the conceptual schema if you change the physical, storage details? Okay, if you change the data structure, okay, if you create a new index, for example, if you create a new index, will the conceptual schema change? Will the conceptual schema change? Okay, the no. Okay, it will not change, right? So I can say this is basically independence of conceptual schema from physical changes. And what is logical data independence? What is logical data independence? It simply means that if you change the conceptual schema, then external schema should not change. Okay, external schema unchanged, external schema independence, external schema independence from logical changes, from conceptual schema changes, from conceptual schema changes. Okay, let's see one by one. This is very simple. This physical data, this is actually very simple. Physical data independence. What this says, the physical data independence. What this says that, just think about it. A very simple point I'm asking you. This physical data independence. Okay, what this means? Let's assume you have a table in a university. Okay, let's assume you have a conceptual schema, and let's assume there are 4 tables. Okay, let's assume there are 4 tables. Now, if I create some new index, if I add new index, let's assume I add 2 new index, then will the conceptual schema change? Will you change the conceptual schema? You will not change, right? The conceptual schema will not change. Will something change? If you add 2 more indexes, will something change? Efficiency will change. Yes or no? Very fast you can access the data. I agree or not? Very fast you can access the data. Efficiency will change, but conceptual schema will not change. So if you add some index, or for example, if you delete some index, let's assume you have 5 indexes, okay, different on 5 attributes. You have index on name, you have index on primary key, you have index on date of birth. You have index on age. Okay, so you have different indexes. If you delete some of those indexes, then what will happen? Then also conceptual schema will not change. Then what you will change? Basically efficiency will change. Yes or no? Efficiency will change, but conceptual schema you will not change. Okay, is it possible, is it possible that conceptual schema will change because of physical changes? Is it possible that because of physical changes conceptual schema will change? It is possible, it is possible, but it is very rare, very rare. The DBMS software, this DBMS software, it is so, I can say it is like a perfect, it is like a perfect software. It is like it is very accurate. Okay, so when you change the physical storage, then you don't have to worry about the conceptual changes. Is this clear? Sometimes it can happen, like, okay, if you completely change the physical, okay, like if you make everything, if you change everything, then something can happen. Okay, then something can happen. But if you change some small things, if you change the data structure, if you change the indexes, if you add indexes, if you delete indexes, okay, if you do some small changes, if you keep doing, then conceptual schema will not change. Is this clear? Tell me, is this clear to everyone? So basically this physical data independence, what it tells you, the physical data independence, what it tells you, it tells you how much physical data you can change, how much physical change you can do without changing the conceptual schema. Is this clear? This physical data independence, it tells you how much physical schema you can change, how much physical schema you can change, so that you don't have to change the conceptual schema. Is this clear? Tell me. So this physical, tell me, is this clear to everyone? So how much physical schema you can change, how many physical details you can change, how many physical details you can change without changing the conceptual schema. Okay, and who will help you? Who will help you so that you can change the physical schema without worry about the conceptual schema? Who will help you so that you can change the physical schema? You can change, like, for example, today you have B tree. Let's assume on the physically you are storing the data using B tree. To next day you want to use some other data structure. Then who is giving you this freedom to use another data structure? Who is giving you this freedom? DBMS. Okay, this DBMS software, this DBMS software is providing you this facility. Is this clear? The DBMS software is providing you this facilities. Just think about it. You have a, let's assume you have an app. Okay, you have some app, or maybe Dream 11, or I can say Zomato or Swiggy. So let's assume that app you have. Now let's assume you decide to change the physical. Okay, you decide to change the physical changes. You want to do some physical changes. Then you don't have to worry about the conceptual schema. Okay, and who will make sure? The DBMS will make sure. So is this clear to everyone? So remember, very simple thing. So the physical data independence, what it tells you, it is a measure. Please understand this statement. It is a measure how much physical changes you can do without changing the conceptual schema. Read this line. How much physical changes you can do? How much physical changes you can do without changing the conceptual schema, without changing the application programs based on conceptual schema. Okay, so this is the idea. When I say application programs, so here I'm talking about application programs based on conceptual schema, based on conceptual schema, based on conceptual schema. Okay, so this is your physical data independence. So basically the DBMS software, it is making sure, the DBMS software will make sure that you can do many changes here. You can do many changes here. You can do many changes here without worry about here, without worry about here. Okay, so DBMS software will make sure, the DBMS will make sure that you can change your data storage. Okay, how are you storing the data? You can change it without making any changes here. Okay, without making any changes here. So very simple. Tell me, is this clear to everyone? So this physical data independence, I can say, okay, so the DBMS software, the DBMS, okay, gives this DBMS provides us facility, provides us facility, to change, storage details, to change physical details, physical, or I can say storage details. Okay, to change physical details without worry about without worry about conceptual schema, without worry about change without worry about conceptual schema. You don't have to worry about conceptual schema. Okay, without worry about conceptual schema. Or I can say, or I can say that, or I can say without changing the conceptual schema. Or I can say without having to change conceptual schema. Without having to change, without having to change conceptual schema. And without having to change all the programs that are based on conceptual schema. Without having to change application programs based on conceptual schema. So without having to change application programs that are based on application programs based on conceptual schema, based on conceptual schema. Okay, so these changes you can do. Clear? Let me know. Okay, so very simple. So this is your physical data independence. Physical data independence, very simple, that you can change the physical this physical changes. You can do physical changes without worry about the conceptual changes. Okay, you can do the physical changes without changing the application programs which are based on conceptual schema. Okay, without changing the application programs based on conceptual schema. Now let's move on the next. Okay, tell me one more thing. Is it easy? This physical data independence, is it easy? Physical data independence, it is somewhat easy. Like, it is not as hard as we will see the next. The logical data independence we will see, that is more harder, that is more complicated. But can you notice, just tell me very simple thing I am asking you. If you do some physical changes, okay, just logically you think, okay, you use your common sense. Tell me, when you do physical changes, like if you add some index, if you modify some index, if you delete some index, okay, if you change the data structure, if you do some small physical changes, okay, I can say, if you do some small physical changes, it is very rare the conceptual schema will change. Yes or no? It is already very rare. It is already very rare. It is already very rare that conceptual schema will change. Agree? It is already very rare that conceptual schema will change. Agree or not? Conceptual schema changes. So here, how much work DBMS have to do? Okay, not big amount of work. Yes or no? So it is already very rare. Already very rare. So if you change the physical changes, if you do some physical changes, then it is already very rare that conceptual schema will change. Okay, it is already very rare. And if you add DBMS also, it is already very rare. Okay, it was already very rare. It was already very rare. But if you add DBMS also, if you add this DBMS software also, then it will become more rare. Okay, then basically it will become almost perfect. Yes or no? Then it will become almost perfect. So I can say that it is already very rare. And if you add the DBMS software, then it will become almost perfect. It will become almost perfect. I can say it will become almost perfect. Clear? Is this clear? So DBMS software does not have to do much work. Can I say? Can I say DBMS software does not have to do much work? Yes or no? DBMS software does not have to do much work. Like, comparatively, it does not have to do much work. Comparatively. Okay. So I can say less work. So it is easier for him. For DBMS software, it is easier to get the physical data independence. Okay, because when you change the physical storage, the physical changes, if you do, it is already very rare the conceptual schema will change. If you add index, if you delete index, if you change the data structure, okay, if you make some physical changes, some small physical changes, if you make, okay, how the data is stored, those physical changes if you make, then it is already very rare that conceptual schema will change. Okay, so now if you so DBMS software does not have much difficulty. The DBMS software has less work to achieve what? Less work to achieve physical data independence. Okay, less work to achieve physical data independence. Is this clear? Less work to achieve physical data independence. Now let's see logical data independence. This is interesting. Tell me one thing. Let's assume this is your conceptual schema. Let's assume this is your conceptual schema. Now based on that, what you will do? Here, who is there? Who is here? The application programmer is here, correct? here you have application program, or I can say application programmer. So this application programmer, he's here, and he will create what? He will create what? He will create external schema. Okay, from the conceptual schema, he will create the external schema. Okay, so let's assume there is there is an application program, and let's assume this application program, this is creating, okay, to create, let's assume to create external schema 1. Okay, is this clear? Tell me. So let's assume there is an application program to create external schema 1. Now tell me. Now, very simple thing I'm asking. Let's assume maybe it is maybe it is using, maybe you are using two tables here. Maybe you are using two tables of conceptual schema. Maybe you are using two tables of conceptual schema to create ES1. Is this clear? Maybe you are using two tables of conceptual schema to create, in this conceptual schema, let's assume you have R1, you have R2, you have R3, you have R4, and let's assume you are using two tables to create this external schema. Now tell me. Now, okay, very simple question I am asking you, and you tell me this very simple question, that forget about DBMS, just use your common sense. Okay, you are writing a program. This program you are writing, and this program you are writing to create an external schema. It is like this. For example, let's assume this is your external schema. Your external schema is this: student name and age. Student name and age. Okay, and let's assume on this also student name, student age, and something, maybe something else, maybe, okay, something else, current city. Okay, so let's assume, so you are using these two tables to create this external schema. Now here, let's assume in this you have date of birth. Let's assume here you have a student name and date of birth. Okay, and let's assume here you have the current city, and here you have the current city, and here you have the current city. Then ultimately what you are doing, ultimately you are creating this. So from R1, R2, you are creating this external schema. Very simple question I am asking you, and you tell me, if I change the conceptual schema, and remember, this is not stored. Remember one more thing, this is not stored. This is very important point. That is the reason I told you this external schema, remember, okay, remember, this external schema is not stored. So remember, external schema not stored, not stored. This is derived, from conceptual schema. By whom? This is derived from conceptual schema. By whom? By application programs. By application programs. Okay, correct? Yes or no? So this is derived from conceptual schema by application program. Now, if I change the conceptual schema, then how much possibility that it will change? That I will have to change this. How much possibility? Tell me, will I change this or will I change this? Tell me which I will change. Tell me. If I change the conceptual schema, will I change this or will I change this? This is the user requirement. This is the user requirement. This is the user requirement. So I again have to provide this facility. If I want to run my business, if I want to keep running my business, then I have to do what user wants. Yes or no? Agree or not? Okay, yes or no? Any company, if it wants the users, okay, then it cannot change this. This is the user requirement. Agree or not? Agree or not? This is the user requirement. So if you change the conceptual schema, there is a high possibility you have to change this program. Agree or not? There is a high possibility you have to change this program. Agree or not? This is your application program. There is a high possibility you will have to change this program. So now the DBMS work, will come. So DBMS has a responsibility. Okay, what you are expecting from DBMS? What you are expecting from DBMS? Now the DBMS will come. What is your expectation from DBMS? Tell me, what is your expectation from DBMS? Our expectation from DBMS, what is that? Just tell me, very simple point. Very simple point. Our expectation from DBMS. Our expectation from DBMS, that is, okay, this is our expectation, that, okay, changes in conceptual schema should not lead to, okay, should not lead, or I can say should rarely lead, should not, or rarely, as less as possible. Okay, so I can say changes in conceptual schema should not lead to changes in changes in external schema application programs. Tell me, is this clear? Is this crystal clear? Tell me what I'm saying. Very simple point. Like in your conceptual schema, this data you have R1, R2, R3, R4. This data you have. So this data is actually stored on the database. This data is actually stored in this table. R1 you have as name and date of birth. In table R2 you have current city. But what user is wanting? This is what user wants. Agree or not? This is what user wants. Remember, user is God, customer is God. So you cannot. This is what user wants. Remember, what this is what users want. This is the trending. This is what users want. This is the trending, I can say. Yes or no? This is the trending thing. Okay, let's assume this is the trending thing. So what you will do? You will create a program. This program you will create. Okay, now you can notice that if I change the conceptual schema, now if I change the conceptual schema, then remember it was derived. Remember, this was derived. This was derived from the conceptual schema. This external schema, this was derived from the conceptual schema by application program. So if I change the conceptual schema, if I make some changes, for example, if I delete this R1, or maybe if I divide this R1, yes or no? If I divide this R1, then what will happen? If I divide this R1, now what will happen? If I delete this and I create two tables, I delete this and I create two tables. I create two tables. Then what I have to do? Then I will have to change this also. Now I will have to change this also. Agree? Now I will have to change this also. This application program I have to change. Now this application program I have to change. Agree? Crystal clear? Tell me. This concept. Is this concept crystal clear? All the dots, are they connected? Okay, are you getting the complete visibility? Like, can you visualize everything that is happening here? Can you visualize everything that is happening here? Is there any confusion, any ambiguity, any kind of, I can say, uh, lack of clarity? Tell me, is there any confusion? Is this clear? So very simple, that if I change the conceptual schema, then there is a very high possibility. There is a very high possibility if I change the conceptual schema, like if I change this, then there is a very high possibility that application program I have to change. Okay, so what I'm saying, that what is our expectation from the DBMS? Our expectation from the DBMS, what is that? This is our expectation, that changes in conceptual schema should not, or rarely lead to changes in external schema application program. Okay, is this clear? Is this clear? Tell me. Very simple. So this is what DBMS will do. So the DBMS, what it will do? Now the DBMS has to do a lot of work. So this DBMS, what it will do? It will make sure, it will provide you, it will provide us, okay, it will provide us logical data independence, or you can call it conceptual data independence. So it will provide you logical data independence or conceptual data independence. Okay. Okay. Should not lead to, or rarely lead to. Yeah, the statement is correct. The statement is correct. Okay. Arnav, this is our expectation. We are expecting this from the DBMS. Our expectation from the DBMS. This is what we are expecting, that you can change the conceptual schema without changing this application program. Life would be very good. Arnav, life would be very good if we can change the conceptual schema without rewriting these codes again and again. Yes or no? Life would be very good. Is this clear? What I am saying, Arnav, I am saying that if you change the conceptual schema, then it is possible. It is very much possible. It is very much possible that we have to change the external schema application program. Yes or no? If we change the conceptual schema, then it is very much possible that we have to change the application program for external schema. But we don't want that. Yes or no? Agree or not? We don't want that. For example, if you are changing the conceptual schema and every time you are changing these application programs, all these application programs, let's assume there are 100 application programs for 100 different external schema. Let's assume you are providing 100 different external schema For those 100 different external schema, there are 100 different application programs. Okay, and if you change the conceptual schema, then what you will have to do, you will have to rewrite these, you will have to delete all these programs, you will have to delete, you will have to create new programs. Yes or no? You will have to create new external schema application programs, you will have to create. We don't want that. Yes or no? I am just telling you that this is the problem. I am telling you the problem. Now who is giving you the solution? I told you the problem. I told you the problem. But who is giving you the solution? DBMS is giving you the solution. Okay, this DBMS software, it will give you the solution. It will make sure, it is responsibility of DBMS. Okay, you are purchasing DBMS. DBMS is very I can say very costly. If you Google, just Google Oracle DBMS cost. Okay, Google it. Oracle DBMS cost. If you purchase that DBMS, it will I can say it will cost a lot. So you are having some expectation from the DBMS. So it is the responsibility of DBMS to provide, to make sure that you can change the conceptual schema. Okay, and very rarely you have to change the external schema application program. So this is the, I can say this is the responsibility of DBMS software. It is the responsibility of DBMS. Okay, it is the responsibility of DBMS to provide us logical data independence. Is this clear? This is the responsibility of DBMS to provide us logical data independence. We are giving money, you should provide us this facility. Yes or no? Agree or not? Yes or no? Like in Go classes, you are paying the fees. So it is our responsibility to make sure that your concept become clear, to give you conceptual clarity. That is our responsibility. Yes or no? So there was a problem. Okay, you have a problem. What is the problem? Every gate aspirant has a problem. What is that? Conceptual clarity. They don't understand concept. Okay, someone will teach a concept, but they don't have the conceptual clarity. Okay, but it is our responsibility. You are giving us money. Okay, you are paying fees. Now it is our responsibility to provide you conceptual clarity, crystal clear clarity. Okay, this word, I use this word very much. Like, is this concept crystal clear? Like, do you have any ambiguity? Do you have any confusion, any ambiguity, any doubt? Okay, so is the concept crystal clear? That is our responsibility. Okay, so we will make sure that we give you conceptual clarity. Similarly, DBMS will make sure that it provides you logical data independence. So what is the responsibility of DBMS? Tell me, what is the responsibility of DBMS? So DBMS responsibility is this. So the DBMS will provide you logical data independence. And what is the logical data independence? So tell me now, what is the logical data independence? What is this statement? What is this data independence? Logical data independence. This means that changes in conceptual schema, okay, not lead to changes in external schema application program. Okay, this is your idea. Is this clear? Tell me, very simple. So this is your logical data independence. Logical data independence, that means how much conceptual schema you can change. Is it perfect? Can DBMS provide you perfect? Can this be perfect? Can DBMS provide you perfect logical data independence? No, it cannot provide you. Yes or no? Okay, so changes in this cannot provide you, but okay, not perfect, but it will provide you. It will make sure that very rarely you have to do this. Okay, very rarely you have to do this. Okay, yes or no? It is not perfect. It cannot be perfect. Just think about it. It cannot be perfect. Why it cannot be perfect? Because in the conceptual schema, if you make some change, then maybe you can make any changes you can make. For example, you can delete the date of birth column. Yes or no? If you delete the date of birth column, then can DBMS do anything? If you delete the date of birth column, can DBMS provide you age? Can DBMS provide you age? This DBMS software, can this DBMS software provide you age? No, it cannot provide you the age. Yes or no? So very simple that. So I can say how much you can change, how much conceptual schema you can change without changing the application programs without affecting the application programs for external schema. Is this clear? How much conceptual schema you can change, how much conceptual schema you can change without changing the application programs for external schema. Of course, it cannot be perfect. These things cannot be perfect. So this is the responsibility of DBMS. What is that? So remember, let me tell you again, this is the responsibility. This is the responsibility of DBMS. This is the responsibility of this DBMS software. Okay, so this is the responsibility of DBMS software to provide us physical data independence, also provide us logical data independence. To provide us physical data independence and to provide us logical data independence. They cannot be perfect. Remember, they cannot be perfect. Like it cannot be perfect 100%. They cannot be perfect, but okay, but I can say close as much as possible, but as much as possible, as much as possible. Okay, cannot be perfect. This independence cannot be perfect. This independence. So this data independence, this cannot be perfect. This data independence cannot be perfect, but as much as possible. Okay, so this is the idea. Now tell me, which data independence is more difficult to achieve? Which data independence is more difficult to achieve? Tell me, PDI or LDI? PDI or LDI? Which is more difficult to achieve? For the DBMS, from the DBMS point of view, which is more difficult to achieve? Why? Why LDI is more difficult? Everyone is saying LDI is more difficult. Everyone is saying LDI is more difficult to achieve. This is more difficult to achieve. But why? Tell me why. Yes, yes, very good, Nikhil, very good. Nikhil is saying बहुत dependency है. Very good. Okay. Okay, both dependency. That's correct. Because you can notice, okay, very simple point. Why the okay, so the answer will be this. The answer will be LDI. This is more difficult to achieve. For the DBMS, this is headache. From the DBMS point of view, from the database software point of view, this is the headache. You can notice why. Very simple point. Okay, where is more tell me this conceptual schema. This is your conceptual schema. This is your physical schema. This is your physical schema, and this is your external schema. Where is more dependency? Where is more dependency? Here we have more dependency, or here we have more dependency? Here we have more dependency, or here we have more dependency? Here we have more dependency because it is derived. Because it is derived, it is not stored. Because this external schema is derived. This external schema, this is derived. Yes or no? Yes or no? This external schema, this is not stored. This external schema, this is not stored. This is derived by conceptual schema. Okay, so very simple. This is derived from conceptual schema. Now very simple, very okay. Just use your common sense. Okay, don't worry about anything. Just use your common sense. For example, if I decompose the table here, you are writing a program. Let's assume. Okay, this is derived, and you are writing a program. You are writing a program, and there is a relation R. You are using the relation R, and here you have relation R. Okay, now tell me, in the next step, what I do? Okay, in the next step, so let's assume here let's assume you have an application program, and in this application program you are using the relation R. Okay, this is your application program. Let's assume this is your application program. Now let's assume this R you have here. Okay, this R. Now suddenly what I do? I change this R to R1, R2. I decompose this. And this happens, yes or no? This can happen very frequently. Now what will happen? This can happen. I can decompose. Okay, maybe I can create a new table. Okay, something like that. Then what I have to do? Now this program I have to change. Yes or no? Now this application program will be changed. Okay, what will happen? Now this program will be changed. So now this program will be changed, and it will use R1, R2. Now it will use R1, R2. Agree or not? Okay, so you can notice that. Okay, this is the point. So which is so this is derived by conceptual schema. Okay, and this is not stored. This external schema, this is not stored. And tell me one more thing. If I add one index, if I add to one more index, will you change the conceptual schema? If I add one more index, will you change conceptual schema? No. DBMS does not have to do anything. Yes or no? DBMS does not have to do anything. Okay. Similarly, if I delete one index, will I change the conceptual schema? No. Again, DBMS does not have to do anything. Can you notice that on most of the occasions, DBMS does not have to do anything here? Yes or no? Here, on most of the occasions, DBMS does not have to do anything. Here, on most occasions, on many occasions, DBMS does not have to do anything. On many changes, on many physical changes, DBMS actually does not have to do anything. On many physical changes, okay, DBMS does not have to do anything. Does not have to do much. Okay, so something like this. Priya is saying that if I divide R1 R2, then it will change the physical schema also. Priya, that is what you are saying, that is correct. But okay, you are understanding this in the wrong direction. This PDI is here. You are understanding this in the wrong direction. Basically, if you change the conceptual schema, physical schema will change. But when I say physical data independence, I am talking about which changes leading to which changes. Tell me. When I say physical data independence, am I saying, okay, these are the two statements, which is correct statement? These are the two statements. Physical data independence, which is correct? Physical data independence, which statement is correct? Okay, changes in conceptual schema not leading, not affecting, not leading to changes in physical schema. Okay, not leading to changes in physical schema. Is this statement correct? Is this statement correct, or is this statement correct? Changes in changes in physical schema not leading to changes in logical schema. Which statement is correct? Tell me. Which statement is correct? Which statement is correct? Physical data independence. Which statement is correct? Which statement? Find correct statement. Which is correct? Tell me which is correct. Anyone? Which is correct? So the answer will be this is correct. Okay, this is not correct. This is not correct. Is this clear? Priya, is your doubt clear? Tell me, Priya, is your doubt clear? So remember, physical data independence says that if you change the physical structure, if you make some physical changes, then you should not make logical changes. Yes or no? If you make some physical changes, then you don't have to make logical changes. Is this clear, Priya? Tell me, is this point clear? Okay, so this is your physical data independence. Physical data independence says that if you make physical changes, then you don't have to make logical changes. Okay, so very simple. So finally, I can say that this is the question, and this is actually a GATE question. Let's see this GATE 1994 question, GATE exam, GATE Computer Science 1994. Logical data independence is easier to achieve than physical data independence. Tell me, is this statement true or false? Logical data independence, this is easier to achieve than physical data independence. This statement is false. This statement is false because, and what is the correct reason? Tell me, what is the correct reason? What is the correct reason? And what is the correct reason? Actually, many students, they don't understand the correct reason. They just by heart something. Okay, they will by heart this. Let me tell you. If you check, then many students, they will by heart this. They will by heart, okay, I will, this is just a simple statement. I will by heart. Okay, yes or no? Because it has come in the GATE exam, and this is simple statement. I don't really understand what is physical data independence. I don't really understand what is logical data independence. Okay, so no problem. I will not put efforts. Okay, I will just remember it. Okay, this is what happens. Many times this happens. Yes or no? So many times students do this. Maybe you have seen this. Okay, have you seen this approach? Have you seen this approach? That, okay, so many times it happens. Okay, so they will just by heart this. They don't really, or maybe they will fool themselves, or maybe they will create something they will create in the mind so that they can remember this. Something they will create in the mind, some logic they will create in the mind, so they can remember this. Some wrong logic they will create in the mind, so they can remember this. Okay, so like in the TOC, in the theory of computation subject, I have seen this many times. People by heart decidability table. Yes, the decidability table people by heart. But one more thing, to make sure, that they remember this, they make many wrong arguments. They say that, see, context free languages are not closed under complementation operation, so CFL are not decidable under complementation. So this type of statements, not closed means not decidable. This type of statements also they by heart. This is not correct. We will, okay, I will tell you, I will give you some examples. I will give you, not closed does not mean not decidable. Have you done this? Have you by hearted like this? Not closed means not decidable. It is not closed, so it is not decidable. That is wrong. This logic is wrong, completely wrong. This logic is completely wrong. Okay, this logic is completely wrong, but still people do this, and in their mind they are thinking that this is the correct logic. In their mind they are thinking that this is the correct logic. What I know, this is the correct logic, because my hulu hulu god teacher, he told me this logic. Okay, so something like that. Okay, so this happens anyway. So anyway, this is the correct, what is the correct reason here? So the correct reason will be logical data independence and physical data independence. So logical data independence is harder. What is the reason? What is the reason? Because the correct reason is very simple, that this external schema is derived. Remember, this is derived. Please understand, this is derived, not stored. This is derived, not stored. Okay, by conceptual schema, from conceptual schema. By whom? By whom? From conceptual schema. By whom? By application programs. Correct? By application programs. Is this clear? So remember, this external schema, this is derived. This is derived. This is not stored. This is derived. This is derived from conceptual schema. From conceptual schema by application programs. By application programs. Okay. So if so, so changes, so changes in conceptual schema. Okay. Okay. So changes in conceptual schema, very, I can say, very much possibility. Okay, very much possible. So changes in conceptual schema, very much possible, very much possible that you have to change this application program. Okay, changes in application program, you have to change this application program. This is very much, this is very much possible. Yes or no? So it is a very headache for the DBMS software. Agree or not? For the DBMS software, it is very much headache. Okay, so very much possible, if you change the conceptual schema, it is very much possible that you have to change the application program. So that is the reason, that is the reason achieving this. So this becomes very much headache for the DBMS software. Okay, so this is a very complicated. This, okay, but we don't want this. Okay, if you change the conceptual schema, we don't want to change the application programs. We don't want to change the application programs. So DBMS should make sure this. So DBMS will make sure this. So that is the reason this logical data independence, this is harder to achieve. So this is difficult to achieve. Okay, this is a difficult to achieve. So I can say this is very difficult to achieve. Okay, this is difficult to achieve. Clear? This is difficult to achieve. Okay, so this is your question. This is your GATE exam question. So tell me, did you understand all the concepts? Each and every concept. This concept of 3 levels of schema, is this clear? 3 levels of schema. There are 3 levels of schema: physical schema, conceptual schema, and there is a external schema. Okay, and remember, many people, they don't understand this external schema. What is this external schema? What is this external schema? Did you understand? Did you really understand what is this external schema? Basically, in the external schema, we are giving what user is wanting. Yes or no? We are giving what user is wanting. What is trending? Yes or no? To improve our business, to improve the business, we are giving the user what user is wanting. Okay, if user is wanting age, we are giving age. If user is wanting current city, we are giving current city. Okay, something like that. Yes or no? So because remember, current city will keep changing. Yes or no? Current city will keep changing, but hometown will not change. So we will store hometown in our database. We will store the hometown, but we will not store current city. The current city we can derive maybe from the GPS or maybe from somewhere. Okay, from some tables, from 2 3 tables, we can derive the current city. Similarly, from the date of birth, we can derive the date of from the date of birth, we can derive the age. Okay, so this external schema, basically we are giving user what the user is wanting. Yes or no? Okay, so this external schema we are creating from the conceptual schema. We can create many different type of external schema we can create. And tell me, when you are creating a new external schema, then why you are creating that? Why are you creating a new external schema? Depending on the user requirement, depending on the market requirement. Yes or no? Depending on the market requirement, you are creating the new application program you are writing. So you will write a new application program to create a new external schema. Okay, now very simple. So your physical schema means how the data is stored. Conceptual schema means what data is stored, and physical and external schema means how this data will be used, or I can say how the data will be visible to the user, how the user will see the database. Okay, so this is your 3 levels of schema. Why we want these 3 levels of schema? What the reason we want this 3 level of schema? Because we want data independence. Yes or no? Because we want data independence. If you make some changes on the physical level, then you should not make changes on the conceptual level. If you make some changes on the conceptual level, you should not make some changes on the application programs of external schema. Is this clear? Tell me the complete thing. Okay, so very simple. Now Debanjan is saying that physical schema is derived from conceptual schema. Yes, tell me Debanjan, first who came? Physical schema will come first, or conceptual schema will come first? Who will come first? Conceptual schema or physical schema? Conceptual schema will come first. So first you have the conceptual schema, then you will decide that how to store this conceptual schema. Yes or no? Are everything is conceptual schema. Everything is conceptual from the DBMS point of view, from the database point of view. Everything is conceptual schema. Now you will decide how to store this, which data structure to use, which indexes to create. Okay, so that's the point. Is this clear? So this is the final. This is the conclusion. Let me tell you, this is the conclusion that so what is the conclusion? So this is the conclusion. If you change the physical, okay, if you changes in physical schema, changes in physical schema, changes in physical schema should not should not lead to changes in should not lead to conceptual schema, should not lead to changes in conceptual schema. What this is called? What this is called? Tell me what this is called. What this is called? This is called physical data independence. This is called physical data independence. Okay, remember this is not correct. This is not physical data independence. Okay, this is not physical data independence. Like this is not physical data independence. Physical data independence is this. Similarly, changes in conceptual schema, changes in conceptual schema, they should not lead to changes in they should not lead to changes in external schema application programs. External schema application programs. Okay, this is called what? This is called logical data independence. This is called conceptual data independence or logical data independence. This is the final conclusion. Okay, only to explain this thing, many students by heart this. Okay, many students will by heart this, but just to explain this conclusion, I have explained it. Okay, everything about this conclusion I have explained. Is this clear? Okay, so very simple. Okay, so this is the another question. Tell me what will be the answer. What will be the answer here for this question? What does physical data independence allow the data administrator to do? Okay, what this physical data independence, what this physical data independence allow you to do? What this allow you to do? It allows you to change conceptual schema without changing internal schema. This is wrong. Remember, option A is wrong. Correct? Option A is wrong. Change the internal schema. Internal schema means physical schema. I told you this. I told you this. Internal schema means physical schema. So what is internal schema? That is your physical schema. Okay, so that is your physical schema. So remember, change in physical schema without changing the conceptual schema. This, yes, that's correct. Yes or no? That's correct. And what about this? Change in external schema without changing the conceptual schema? No. And what about this? Change in application programs without changing the internal schema? This is also not correct. Okay, which of these statement is a logical data independence? Which of these statement is logical data independence? Which of these statement is logical data independence? Which of these statement is logical data independence? None of them. Are none of them. Which of them is correct? So none of them. Again, you are making the mistake. The option C is the other way around. Option C is the other way around. Again, you are making the mistake. Option C is the other way around. Yes or no? Option C is the other way. So if I change the option C like this, changes in okay, if I change like this, changes in conceptual schema without changing the external schema. Changes in conceptual schema without changing the external schema. Now this will be correct. Yes or no? Changes in conceptual schema. Changes in conceptual schema without changing the external schema. Okay, without changing the external schema. Now this is correct. Is this clear? Now this is correct. I can also say that this also will be correct. Changes in this also will be correct if I do this. Changes in conceptual schema. Changes in conceptual schema without changing the application programs. Without changing the application programs. Okay, this is also correct. So this option D is also correct. This option C is also correct. Okay, both are correct. So that's it. Is this clear? Is everything clear? Okay, shall we move on now? Now let's solve some questions. So, okay. So should we take a break? So let's take a break, and after the break we will solve some questions. Some questions we will solve. 5 questions I have taken. 5 or 6 questions I have taken. So what we will do? Okay, let's take a break now. But after 15 minutes we will start again, and we will solve some questions. Okay, and then we will have another session in the evening. Okay, in the afternoon. Okay, maybe 2 p.m., 3 p.m. You can tell me at what time. But we will have another session, and in that session I will cover few more questions. Okay, so in the evening we will have another session. In basically I will cover questions in the normalization. Every concept we have seen, every concept, each and every concept we have seen in the normalization. Okay, you can attempt the test at this point of time, at this, okay, right now at this point of time you can attempt to Go Classes DBMS test 1. Okay, that test you can attempt. But remember, I will do some more questions. I want to do some more questions in this normalization. So now let's take a break. Okay, after the break we will solve some 5 or 6 questions we will solve, and then we will start in the evening. We will start, maybe we can start at 4 p.m. Okay, we can start at 4 p.m. Okay, some questions I will solve from 4 p.m. to maybe 5 p.m. Okay, some questions, again some 5 or 6 questions I want to solve. Okay, so let's take a break now. Mavit, I'm not getting your doubt. Okay, let's take a 20-minute break. So we will start at okay, 10:15. Okay, we will start at 10:15. What is your doubt? Please tell me. Anyone has any pending doubt? Anyone has any pending doubt? Mavit, I am not getting your doubt, like what you are asking. This physical schema, this we will study in the indexing chapter. There is an indexing chapter, there we will study. Database is made up of Yeah, that will clear. We will study B tree, B plus tree, how everything is actually stored in the hard drive, how DBMS, how the database is actually stored. Okay, how you will store the database, what data structure you will use. Okay, how the records will be stored, how the indexes will be created. This we will study. This is in the syllabus. There is index chapter, I told you. The fourth module, sorry, yeah, okay, the third module. So first normalization module, then relational algebra, SQL, and then we will study indexing. This indexing we will study. Then we will study the um, transaction management, and then we will study the ER model. ER model we will study at the end, because that is a complete different chapter. Okay, the ER model, that has nothing to do with anything else. Okay, all these other things are linked. All the four modules: relational model, normalization, your indexing, your queries, SQL, relational algebra, and your so transaction management. All these things are connected to each other, but ER model is completely separate. Okay, any doubt, any pending doubt, Mavit? Any pending doubt? Okay, see you at 10:15. Thank you.